Hello again. In this activity, we talk about the urban heat islands. So in this activity, students compare the temperatures in various spots in and around their schools and neighborhood to discover the formation of heat islands in urban environments. Moreover, they will critically reflect on the disappropriate impact of heat on the city's poorest and most vulnerable communities. It is suggested for students older than 11 years old, and during the activity we apply the methods of brainstorm, group work, and field research basically through the elements of the scientific methods, which is data collection, data analysis, and data interpretation. For materials, we will need a couple of IR sensors for measuring the temperatures, some maps, some notebooks, and the worksheet that we need to reproduce. So the activity comes in three parts. The first part is the preparation. It takes one class hour, around 45 minutes. And then we have the field study, and then as a final third step, the synthesis. In the first session, we start by asking students to guess what could the term heat island mean. What could it mean? They start telling various ideas, and we ask why are cities heating more than suburban or rural areas, why some parts of the city heating more than others. We can share some photos with them of the phenomenon. Such as this photo on the right, taken from a Spanish city in 2024, I think it was, when it reached almost 50 Celsius, or the picture in the middle. It's a city in the USA, I think Georgia, and it was taken by NASA. Maybe 2 decades ago, so you can see how the whole city is actually in red, close to 50 Celsius, with only a few green or blue pockets. So then we explain what heat islands are. They appear in cities, and we have the phenomenon of significantly higher temperature than the surrounding rural areas. Where it happens when we have a high population density. We have old non-insulated buildings, usually of concrete. We have lack of green spaces, and the phenomenon is worse at night, when the time difference between the city center and the neighboring areas can be up to 10 Celsius. 10 degrees, because the retained heat in the buildings is then released. So after we explain the concept, we present them a map of their school or of their neighborhood. This is a map. It's actually from Google Earth. It's a screenshot from Google Earth of our neighborhood, where MIO is situated. It contains several landmarks that the students can recognize, such as the church, a square, a monument, so they can find their building, and they can start seeing the green spaces around the school. And as a next step, you create together with the students the routes and the surfaces that they will measure in the field trip. So you add diverse routes. As you see here, we have one in red, which is actually the street of our office. We have one in yellow, that is a square with a more green area. We have a street that has high traffic and tall buildings around, and we expect the urban heat effect to be higher in this street. And then we have a square here where we have the element of water. You create these routes in advance, and you ask students to guess where the heat islands will be, and together you pre-decide the spots or the buildings, the exact buildings where you take the measurements. If you want to do a mini version of this activity, you can do it inside the school campus only. So go to various spots within the school, such as the garden, a corridor, a shaded area, an area under a tree, in order for students to compare the different temperatures. Okay. So the more you prepare in this first lesson, I think the greater the results you will have during the field research. So you can modify the worksheet that we suggest in the activity. You can add the exact spots or buildings that you intend to measure. You will split the groups. Maybe one or two groups take each route. You assign the routes to the groups, and then you ask them all together to go over their worksheets, so know in advance what they will be measuring. Maybe at this stage you can also take some demo degree measuring with the IR, so that the students know how to handle it. The second lesson takes around hours. And for each spot, you encourage the students to observe and make notes of the factors beyond temperature, such as construction material, shade from trees, the presence of water, the ventilation, and so on. And for each spot, they can optionally take a temperature on the ground and 1 meter above the ground. They can note all these in the worksheets. It's important also to have in mind that in order for temperatures to be comparable, they should be taken approximately the same time of the day, for example at noon. And of course, when you move with a class outside the school, needless to say that you take all the safety, you follow the safety protocol in terms of guides and adults that need to be with you, especially if you split the groups. In the third lesson, we come back to class. It takes around 45 minutes, and we synthesize our results. So the groups analyze the data, they compare their findings from the different spots, they identify potential hotspots within their neighborhood, and then you start discussing about possible measures to mitigate the heat stress. We don't expect that this knowledge comes from the students, so maybe we give them some ideas. We talk about the green roofs and the green walls, the planting of endemic trees. That needs to happen with a plan, however, so we might need the help of a garden architect there. The option of installing shade structures like pergolas, installing permeable surfaces such as porous pavements, installing water elements such as fountains, and so on. Also using cool paintings and so on. So after this, we propose the idea as a follow-up to write to the mayor or to the school administration to start as a cool wall or a cool roof initiative. The evaluation can be in the forms of posters that the students create, so you assess both the knowledge and the creativity of students in these presentations. As a follow-up, also you can do the same activity, repeat the activity to the poorest parts of the city center to discover how the urban heat islands affect mostly the poor communities. Why is that? Because they live in dense areas without green spaces, because they live in highly heat-absorbing buildings without insulation, and also because they usually pay more electricity to keep their homes cool in the summer and warm in the winter with air conditioning, and they're also more vulnerable to heat-related diseases. So it's important, even if you don't do the activity of taking measurements in the city center and in the poorer parts of the city, to discuss this with your students in order for them to link the climate change and the climate crisis to inequality. That's all for me. Thank you for your attention.